Hello, this is Mrs. Youd, and today I'm going to be teaching you Chapter 10, Lesson 2, which is graphing cube root functions. A cube root function is when you have a cube root where the independent variable is inside the root. In this case, the independent variable is x. So this right here is the parent function for the cube root functions. Let's go ahead and plug some numbers in there and see if we can figure out why. Okay, I've chosen these to plug in because those are perfect cube roots. So if we plug in -8, the cube root of -8 is -2. So that means that -8, 2 would be a point on this function. You'll notice that this graph here does not quite go out to -8, but you can imagine if you were to follow this out and we were to continue this, it would indeed have a point right about here where -8, -2 would work. If we plug in -1, the third root of -1 is -1, so that means that -1, -1 is a point on our function. We do see that right here on the function there. If we plug in 0, the third root of 0 is 0, so that means 0, 0 is on the function as well, and we see that right at the origin there. And the third root of 1 is 1, so that means 1, 1 is a point on our function, which we do see. And if we plug in 8, the third root of 8 is 2. And once again, just like -8, our graph does not go out that far, but you can imagine that if we were to go out to 8, it would indeed end up right at that spot. So that does indeed work as well. So as you can see, this shape here does indeed make sense for the cube root of x. And like I said, this is the parent function, so all of the graphs that we make today will be compared against that function. In exercises 1 through 6, we need to graph the function and then compare the graph to this parent function here, the cube root of x. So if we think about the transformations that we've learned, if you take a look at this, you'll notice that we have a -3 on the inside of the function. And so what this means is that it's going to take the parent function that we started with and it's going to move everything right 3 units. So I'm going to start with my parent function of just plain old cube root of x. So that is going to cross at the origin. It's going to cross at 1, 1 and -1, -1. And it's going to take on a shape that looks a bit like this, where it comes down and it makes kind of this sideways S shape here. All right, so let's go ahead and now graph the equation that we are given here, the third root of x minus 3. And so in order to do that, I need to take this parent function and move everything to the right 3 units. So the one that passed through the origin is going to be to the right 3 units, and all these other points will be moved to the right. And so my new shape will look something like that. So the one that is blue is my answer. The one that is yellow was my parent function. Okay, let's take a look at number 3. I went ahead and drew the parent function for you. So if you remember what's going on in this case, we are going, if we're multiplying by 4 on the outside, that's going to be a vertical stretch by a factor of 4. So that means that my origin is still going to be there. We're going to have the same point. But instead of going up 1 and over 1, we're going to go up 4 and over 1 and down 4 and over 1. And so it's going to be a lot more stretchy here when we draw our S shape. You go ahead and do number 2 and see, pause the video. I'll give you a hint on number 2. Remember what happens when you add a number or subtract a number on the outside of the function. It means it's going to move it up or down. So go ahead and try that one on your own. Okay, here's what I got. I moved the whole of the parent function up 2 units. Okay, on number 4, I went ahead and drew the parent function. The negative on the outside there, remember, means that's going to reflect in the x-axis. And the -3 on the inside of the function means that the whole function is going to move to the right 3 units. So I'm going to start with my origin here. We're going to start with this one here. We're going to move it to the right 3 units, so it's going to end up there. Now let's take a look at this point here. If we reflect it in the x-axis, it would end up here, and then pulling it right 3 units means that that new point would be here. Okay, looking at this one here, we're going to reflect it in the x-axis, which means we're here. Now we're going to move it right 3 units, 1, 2, 3, which means it's going to be there. And there we have our new S shape. All right, let's take a look at number 6. Okay, I've drawn our parent function in for number 6. So we have a -6 on the inside. The negative means that it's going to be a horizontal reflection, which means it's a reflection in the y-axis. Secondly, we have a horizontal stretch by a factor of 6. Lastly, we have a -2 on the outside of the function, which means the whole shape is going to be shifted down 2 units. Now, since there's a lot more going on this question, let's go ahead and plug some numbers in. If we plug in 0, we're going to get -2 as an output. So that means that our starting spot would be here, and that makes sense because we're going down 2 units. Now I'm going to plug in a -1, and I'm going to need my calculator to help me out on this one because it's not going to give me a perfect nice answer. So that would be the cubed root of -6 multiplied by -1 is +6, and then -2. So using my calculator and rounding, I get that it is about -0.2. So over 1 down -0.2 would be about right here. Okay, let's plug in a +1. So that would be the third root of -6 times +1 is -6 minus 2. And I get -3.8 as an output. So it will be right about there. I'm going to plug in a few more numbers. I'm going to plug in a -4 and a +4 and use my calculator to see what I get as an output. Okay, so here's what I got as outputs. So now I can see my nice S shape forming up here, and there we have our answer. I would like for you to try number 5 on your own. Pause the video and see what you get once you turn it back on. All right, here's what I got. Notice that it's a vertical stretch by a factor of 2 and a vertical translation down 1 unit. That concludes today's lesson, Chapter 10, Lesson number 2, which was graphing cube root functions.